Hello everyone to the demo for CS assignment 3 part 2 by Dhruv Deshmukh. In this I have made my own client server application. The motivation behind this application is if you have ever gone to a restaurant, then in order to place an order, first you need to call the waiter who notes down your order and then gives it ahead for further processing. Now the problems with this is sometimes he may note down the wrong order, thus giving you the wrong item. Uh, and the other thing is that he may not be able to give you a good estimate of how much time is required for your order. This may like sometimes he will say like I will give it in 5 minutes, but you will not get it in that amount of time, and hence there can be some delay in whatever order, whatever time you are expecting to get the order. I with my application I try to tackle these problems. So what my application does, it is an online ordering and notification system. So I have specifically implemented it for the scenario of restaurants, but it can be adapted in different sectors easily, which have similar use cases. So for example, in banks there are queues for certain things. So for these queues also as well, this kind of system can be used. The other such system that is already in working is the Amazon ordering system, where you actually order your stuff and then it gives you a delivery date based on the items that you want, and then that order is processed. Uh, kind of similar thing. So what happens here is clients will send their order to the server. The server will do some processing on these orders one by one and give the clients the notifications till the order is completed. So what features do I implement? First feature is reliability. So I am using a UDP datagram. That's why there is a chance that the packet can get dropped or the order can get dropped. To ensure that it reaches the server and I am acknowledged, I after sending my order, I wait for a timeout, and if I do not receive any acknowledgement within the timeout, then I send the order again. Uh, Now on the server side, if it when the order is initially received, it makes a note of the order, puts it in stores it, and also calculates an estimated time to complete the order. This time is also stored and then finally sent back to the client as an acknowledgement. Now, if a order that was already received is received again by the server, then in that case it will not do this calculation again. It will directly send the time that is expected back to the client as the acknowledgement. Now feature 2 is that the server is not dumb. So in the first application, the echo server was dumb. It just sent back the messages that client that received from the client. Now in this case, the server actually parses the messages that are received from the client. From it understands the order of the client and then calculates a estimated time to complete that order. This time is sent back to the client. Also, the order is queued into a queue on the server side, and then these orders that are placed in the queue are processed one by one. Also, when the order starts processing and gets completed, the client is notified through messages. Now let's go to the demo. So here I have four windows set up. The first window, the top left window is the server window. I have opened it in the server folder, while the other three are the client windows opened in the client folder. So I'll first compile it just to show you how to compile the code. So that the command is this, and then I will run the server. So now our server has been set up. Now what we will do is compile the client code and start our clients at these three terminals. So as you can see, three clients have started. You can assume that these are the three customers that have arrived at a restaurant to order food. So now to order food, I have given a specific format here. If you see it clearly, the format is first you have to mention the table number. Then second is you have to give uh, the dish number, and the quantity of the dish you want. So suppose you want to eat the dish number 5 or dish number 1, and you need two of its two quantities, then you will write it as 1 2, and similarly 2 3 for three quantities of dish 2. So I will place an order similarly. So for the the first table, this order is there. Now for the second table, let's say that the order is this one, and finally for the fourth table, let's say that our order is uh, this one. So now what we will do is send the orders. So I am sending the orders, and the orders can be sent in any sequence. It's not that I'm doing it in a particular order. It's any sequence is possible. So as you can see, the first order that was sent was this one, and hence it has started processing first, and also it has received the acknowledgement. Before that, it resent the order once because it didn't receive the acknowledgement in the required time. So after 20 seconds, the order is will be completed. So here we got completed. Client is closing. Now you can see this next order has started processing, which is this one, and it had wait for 60 seconds. So now it is being processed. Also this one also resent it once. In this case we did not resend the order. The first request itself was acknowledged. So this is the, and in the server you can see whenever it receives an order, it prints the order received and whatever order was there, and then it once it parses the order, it prints the table number, the item, and the quantity every time. And then whenever it starts processing, it prints starting to process the order for table 4, and whenever it completes, it prints order complete for table 4. So like this you can see that it has printed it. Now currently for the last table, that is table 2, the order is being processed, and we'll get the final notification. Here you can see the final notification for client 2 is received. So here also you can see that order complete for client 2 has been printed. So I'll quickly go over the problems that I was going to like tackle and show how they are being solved here. So the first thing is that the order received is wrong will not be a problem because UDP has its checksum, and so it will do the error checking. Then we have the correct estimate. So the server actually knows how exact load that we have, that is the number of items in the queue, which order is being currently processed and stuff. So it can give a pretty good estimate as to how much time will be required for processing the new order that is received. So hence the customer has a very good idea of how much time will be required for his order to be processed, and also that's why it will there is chances of experiencing delays very less. Also to recap, the reliability feature, that is resending the order if acknowledgement is not received, that was shown in the demo as well. And the server is not dumb. The server is doing lots of different things like queuing, calculating the time and processing and stuff. So this is the other thing, the other feature. Now I'll quickly explain the code. So in the code, you can see first is the processing timetable. This is actually used to decide how much time is required to process a particular item in my menu. So I have total 5 items. So that is what I was showing, that item 1 or 2 quantity. So if I am ordering item 1 of 2 quantity, it means it will require 5 seconds for each one. That is 10 seconds in total to process it. And also there can be additional queuing delay if there are orders in the queue before it. Then here you can see I have 10 tables in my hotel. Then I have an order queue. So the order queue stores the table number for the order, the arrive time for the order, the time to process and time to complete, also the client address from which the order is received, and also if an acknowledgement has been sent to it or not. This variable is for that. And finally the contents of the order. The you can see the size of the queue is 10 because I have 10 tables. Um, then these are the front and rear pointers and the queuing delay. These are the utility functions that I have, and this is the receive order function. So this goes in the infinite loop and waits for clients to send their orders. Once the order is sent, it parses the information one by one. First of all, the arrive time is noted down. Then then the table number is parsed first of all, because it's the first part of the order. If the so here this actually stores, this variable actually stores whether a order is received or not. So if order is not received, means it's a new order. For the So it is parsed and the processing delay and stuff is calculated. But if a order is received already, then here this will store the time required to complete that order, and that will be sent back to the client as an acknowledgement. This was what I mentioned earlier. So if it's a new order, then the processing starts. So first it is added to the queue. So one by one we are adding different items. So we are adding the client address, the table number, the arrive time. Time to process is set to 0 first, and then it will parse through the order and extract the item and the quantity, and then accordingly update the contents here. So contents here basically is an array of 5 for 5 items, and it stores the quantity of each item. Then we have this one, that is the time to process. So it goes in a loop, it parses each item and then processes it. So what do I mean by this is that the quantity is multiplied by the processing timetable. So as if two quantity item 1, so 2 into 5 will be 10 seconds. So accordingly the time to process is calculated. Finally the time to complete is nothing but the sum of time to process plus the queuing delay, current queuing delay. This time is also then stored in the tables now, as I said earlier. So if the message is received again, it will acknowledge using this, and the queuing delay is updated now for the subsequent orders. Then this is again the small error mechanism I mentioned earlier. This is just to mimic real life networks. And finally, the acknowledgement that the order is received is sent. This message basically consists the waiting time for the order that was calculated, or the time to complete for the order. This is done inside a lock so that these variables are not accessed by the other thread, that is process orders, in a in on a inappropriate manner. Now the process order again goes in a infinite loop, and it basically till the queue is not order queue is not empty, it will go on, and in each iteration it will take the front order from the queue, and then it will start processing the order. So so if the here it checks whether the acknowledgement for the order is sent. So if the acknowledgement for the order is sent, then it enters and starts processing the order. So it prints that the starting to process the for this table, and then it will update the queue now. That is the first item is removed from the queue now, it's not there anymore. So size of the queue is the front and rear are updated accordingly. Now it will process the order, that is it will go in a loop for that amount of time, which is mentioned in time to process, and it will also update the queuing delay for each iteration. And finally when the processing is done, uh, then it will say that the order is completed, and send a message to the client that yes, your order is complete now. Now these are some initialization structures to initialize the queue and stuff. This is the main function where I actually do the take these arguments. So you can give the server string. So if your server is placed at a particular IP address, you can provide it here in the command line arguments using get address info. Get it will be worked out. Then after the initialization is done, I do the two threads, receive thread and the process thread, which I've explained above, and that's it. This is what the server does. Now the client has again these two server things that I implemented for my convenience. So this is send echo message is actually send order. So what it will do is send its order here, As I explained, it will you have to give the order in the particular format, and yes, the order is sent. Once the order is sent, it will wait. So for the timeout here in the receives thread, receive account say actual receive order, receive acknowledgement or updates. So here it will uh, wait for some time. So till it is expecting, so it will wait, and if timeout occurs, then it will resend the order. You can see it here. But if the acknowledgement is received here in the receive from, then it will wait for the order is processing thing. So if once this order is processing received, yes, first it will print the wait for whatever time is required. So the acknowledgement received has the time waiting time, so that will be printed. And once the order is taken for processing, it will print order is being processed. And finally, when the order is complete and the acknowledgement is received, it will say order is completed. So here again the similar things are there. So this is how the client for client is working. So that is it for this particular part. Thank you.